July 24, 2025 at 7:11 was struck by a BM-21 rocket or a precision bomb. This is part two of the analysis. This is part two, BM-21 rocket projectile motion analysis based on the laws of physics. Facts, to understand how the rocket behaves, you have to understand the range of the rocket. Older rockets can travel up to 20 kilometers. Newer rockets can travel up to 30 to 40 kilometers. The key thing is the rockets do not have guidance. Other facts are that the grads are very inaccurate and imprecise, and the angle in which the BM-21 rocket launcher can launch is at 55 degrees. Some additional data shows that the circular error probable is about 100 meters. Some even shows it to be 200 to 300 meters. The muzzle velocity is noted to be 690 meters per second. This is the speed at which the rocket exits the launcher. Looking at the map, there were 2 points from Cambodia to the 7-11 that were noted as possible launch points. One is 73 kilometers, the other one is 26 kilometers, which is within the range of the newer rockets. Now that we have all the parameters needed to understand the projectile motion, we looked at the physics of the profile and the path trajectory. There's an app called On O Physics, which is available on the internet, and you can vary the velocity, the launch angle, and it'll allow us to see what the motion path is. And note that 55 degrees angle is used as the launch angle. And you can see that the travel path is typical of a parabola. And note that the arrows on the end of the projectile shows the velocity vector, in this case the x and the y component, and the diagonal line is the orientation of the rocket because it does not have any guidance or active fins to align itself vertically. It's going to be dependent on the launch angle. During the launch angle, we can see that the rocket can have a steeper trajectory, but keep in mind that the launcher can only be angled at 55 degrees maximum. There's another app that is available on the internet that can be used to simulate real distances, and this app here does not factor into drag from air resistance and wind conditions, but by changing the height you can travel a bit further, but your angle, trajectory angle is not going to change. Now, based on a muzzle velocity of 690 meters per second, the total flight path is about 116 seconds, covering about 45 kilometers, and this is within the specification of the rated BM-21 rocket, assuming that there is no drag or air friction. Now, this is a graph showing possible illustrations of what the different angles and trajectory would be based on those angles. Now, simulating the flight path, if we use, say, for instance, 59 degrees trajectory showing the BM-21 rocket, you can see that if you're in the line of sight that's in plane to trajectory path, you'll see that the shape may be a vertical. Now, this is very important because on the image of the video we see that the rocket is almost vertical. Now, let's assume that we're coincidentally in the line of sight that's in plane to the trajectory. And what is that going to do? Well, we can figure out what the aspect ratio of what the rocket needs to be by measuring the diameter. And keep in mind that this is a scale of 1 to 10. The full scale model of the BM-21 rocket is 2870 millimeters, and that's shown there is 287. So it's a 1 to 10 scale model. Now, taking that number, the 42 measured, we can calculate what the aspect ratio is. The aspect ratio is just a relationship between the height of the rocket and the diameter of the rocket as viewed from the frontal or side of the rocket. And this calculation kind of shows you what the rocket angle needs to be at in order to meet that aspect ratio. based on the size of the rocket, which is 2870 millimeters in length and 122 millimeters in diameter. Now, looking at the projectile using the sine function, which is taking the length of the rocket and times the sine of the angle, we generate different aspect ratios, and then we arrive at a 16.6 degree angle that it has to be in order to meet the profile of the rocket. So this is kind of a concept that I think it's very important in order to understand if it is a BM-21 rocket, what angle does it have to be in order to meet the image profile, the height to diameter ratio. So that rocket would have to be scaled up, and in the next subsequent analysis, we're going to show you what it has to be scaled up to. So in this case, I did a min and max angle that could be based on the sharpness of the image of that profile. So the minimum angle is at 16.6, and then the maximum angle is at around 25 degrees. And you can see that to the right there, that's the scale at which the rocket would have to be enlarged in order to project that side profile to allow us to see it. And this is very important to understand the trajectory if we assume that the rocket cannot be vertically aligned based on the laws of physics. So going back to the model now, we model the rocket into position, but to do that, I've taken a visual of the 711 and looking at the width and depth of the 711. It's about 20 meters in depth, and then just modeling the 20 meters in length, we see generate a 3D contour that kind of simulates the location of the 711 relative to the graphical image that we have, and assuming that the rocket is centered in the picture before it strikes. And so now we have a box showing what the 711 could potentially look like, or height-wise and width-wise based on the view there. And we see how the rocket can impact, whether it's going to impact down based on that trajectory to hit the 711, or if it's going to miss it. So we go through the process of taking the BM-21 rocket and then positioning it into the model. And we see that, first of all, we create a line, a center line to match the vertical motion, and then using the 3D CAD tool, we generate the angle at which from which we calculated based on what the aspect ratio is. That angle there is around 25.5, and then the smaller angle is around 16.6. Now the scale factors are different. For the smaller angle, the rocket would have to be larger in order to project a straight line meeting the vertical height of the image captured by the dash cam. So that's the height of what that rocket needs to be in order to project to that vertical line, looking from far away to see that projection. The same thing, we do that with the 25.5 degree orientation, and then we try to analyze based on the position of the rocket to see if it actually hits the 711 or misses the 711. Now this is assuming that the BM-21 rocket cannot be vertically aligned or self-orient itself to guide itself to hit the target. So we can see that based on the profile that everything seems to match up. It's particularly the width, that's the rocket, and as it projects, you can see that the height is almost nearly the same, at least towards the center. So it's a good approximation, not 100% accurate, but a good approximation of what that line of sight would be. Next, we rotate it and then we generate some lines to see where it would land and whether it's going to miss the 711 or not. Now this is the interesting part where we start to rotate and then we start to see that, okay, based on the angle that would match the contour of the profile, we see that it would miss the 711, hitting the front of the 711. And from the image there, you can see the two different scales. Not only that the rocket would be very, very out of scale, more than 1 to 2 times, in some cases 3 times larger than the actual dimension in order to generate that that silhouette that we see there. So it's infeasible on many counts that it's not a BM-21 rocket. So conclusion is that based on the laws of physics, the question that to ask is, can the BM-11-21 rocket hit the 711? And assuming that a line of sight is in plane to the rocket's trajectory, the BM-21 rocket must be at 16.6 or 25.5 degrees maximum angle before impact, missing the 711. Another fact to consider is that videos of previous frames or a couple of frames before where the rocket is higher shows that the ballistic also appears upright when it was at higher elevation. And then a straight line connecting both the images show a nearly vertical flight trajectory that's unlikely to be the trajectory of the BM-21 rocket. So the conclusion is that the physics of the projectile motion of the BM-21 rocket shows that the projectile motion as shown in the video and as captured on the image does not match the rocket profile or silhouette, and if so, it would have missed the 711. Moreover, the rocket does not have guidance and active fins to orient itself vertically to strike the 711 as captured in the video. Thank you for watching, and please stay tuned for the next video on accuracy, precision, and CEP of the BM-21 rocket.